Alright, second example, still on the application of Newton's laws of motion, we have this. And so in the figure, the weight is 60 newtons. And so what is the tension in the diagonal string? Find the magnitudes of the horizontal forces F1 and F2 that must be applied to hold the system in the position shown. Okay, and so first, of course, the weight of the object is 60, given at 60 newtons. Assuming, and so we have there the diagonal string, let's have that as T. Okay, first let's have the free body diagram of the problem. And so in the free body diagram, it is evident that there are 2 points that we have to consider. Say that is point A, and then this is point B. And so in each point, there are forces acting. And so on point A, there are 3 forces acting. And then on point B, there are also 3 forces acting on that, so for it to support the weight of the mass, or the weight of the object given in the problem. And so first, let's have point A. And so at point A, let's have that at point A. First force we have there F1, and so it's directed towards the negative x-axis, and we have here tension, or that is actually the force that is present in the diagonal string. And so in this case, or at point A, the direction of tension is towards southeast. We also have a force that is directed upwards. That is now the force that is supporting the entire system. Okay, let's have that. And then the value here, or the angle here, is 45 degrees. Now moving on to point B, and so we have here at point B. So at point B, first, of course, you have there the weight of the object, which is given at 60 newtons. Then we also have the force that is directed towards the right, or that is F2. And in this case, we also have here a force that is equal to the tension. And so in that diagonal string, and so at considering point B, the direction now is opposite to the direction from point A. And so this time, tension is directed towards northwest. And there are also 3 forces acting on that object. And if this is 45 degrees, we could safely assume that this is also 45 degrees. Okay, and so that is the free body diagram of the illustration. Now, first, at point, and so simulan natin sa point B kasi that is where we have our given, which is 60 newtons. Again, the system is still in equilibrium. Therefore, we apply the conditions of equilibrium. First one, and so the summation of all forces along x should be equal to 0. And so what are the forces that is acting along x-axis at point B? And so dito tayo sa point B, ha. First, we have the x component of tension. I take note that, okay, sige, if I'm going to illustrate that, the components, and so we have here tx, and then we also have there ty, right? We have the x component of the tension, and it's directed towards the negative x-axis, so that is negative tx, plus we also have their f2, and so that is now equal to 0. Okay, simplifying that, or transposing now, we have negative tx, we'll be having f2 is equal to tx. Take note that we're looking for f2, and if we're going to expand tx, that is actually equal to t. The angle is, and the cosine theta, or that is cosine 45. We have there f2 is equal to t cosine 45. We don't know the value of t yet, and we don't know also the value for f2. So we keep this first, we keep this equation for later. And so next, and so we can say, and the summation of all forces along y should also be equal to 0. What are the forces along y? First, we have there t sub y, which is directed upwards, so we keep it as positive, minus the weight of the object, it's directed downwards, so negative. And then, altering the equation, you have there ty is equal to w. Okay? And so ty is actually equal to t sine theta. So, if we are going to substitute the values now, or isolate t, kasi we can actually solve for t already. T is equal to w divided by sine theta. Or, substitute now the values, 60 newtons divided by sine 45. That is now equal to the tension, which is equal to 84.9 newtons. Okay, so there we have the value for tension, which is 84.9 newtons. From that, we can now continue this formula. So F2, solving for F2, that is T cosine 45. Since the value is the same, we have 84.9 times cosine 45. We will get there the value for F2, which is 60.03, or F2 now is equal to 60.0 newtons. Okay? And so, basically, equal lang siya dun sa weight. Next, we go to, and so at point A. First, and so we have there, or we consider now the summation of all forces along X. Bakit? Kasi, if you're going to look at the illustration, we only consider the X components kasi yung unknown natin, which is F1, is along X. So, and the summation of all forces along X should be equal to 0. What are these forces? We have negative F1, negative because it's directed towards the negative x-axis, plus we have the X component of the tension, or T sub X. Getting that? T sub X is now equal to F1. And so T sub X is equal to T cosine 45, or that is now the value for tension, which is, did we solve? 84.9, and 84.9 newtons, or let me just so that we will be consistent. And so in your problem solving, you may not write the units yet, as long as your units are consistent. But it is important that you have to write your units when writing your final answer. And so 84.9 cosine 45 is equal to F1. F1, the value of F1 is now equal to, and so 60.03 also, or 60 newtons. Okay, so there, that is for the second problem.